Now this is exercise 4.7, question 12. We've been told that ABCD is a parallelogram, so therefore we know that AB equals DC, and AB is parallel to DC. It's also equal as well, and that AD is parallel to BC and equal as well. We're told that the diagonal BD bisects angle ADC. And they've told us that we're letting angle ABD equal alpha. Now in this first part of the question we have to prove that AB equals AD. Now notice that AB and AD both lie in the same triangle ABD, so we are not required to prove congruent triangles in this case. If we were asked to prove that perhaps AB was equal to another side in the other triangle, then we would use congruent triangles, but because we're just asked to prove that AB equals AD and they are both in the same triangle, then we don't need to prove that this first triangle up here is congruent to the second triangle down there. So let's just use properties of a parallelogram to help us, mainly that AB is parallel to DC in this first case, and we'll start looking for alternate angles. So if we do a backward Z here, we can see that angle ABD is equal to angle CDB and that they're both equal to alpha. So we'll write that out first. So we've got that angle BDC is also equal to alpha because they are alternate angles, and we know that AB is parallel to DC, so we can do our backward Z like that. The other information that we've been told is that BD bisects angle ADC, so if we've got alpha down here, then we also know that this angle up here is also alpha. So we'll write that up as well. So we can say that angle ADB is also equal to alpha because BD bisects angle ADC, and we can put a little alpha in on that diagram as well. Now let's look at what we've got. We've been asked to prove that AB equals AD, and as you can see in triangle ABD we have base angles equal, hence triangle ABD will be an isosceles triangle, and hence AD will equal AB because they are equal sides which lie opposite equal angles in that triangle. So we say therefore AB equals AD because equal sides lie opposite equal angles. Now I've just marked in those equal sides on the diagram, so AB equals AD. Hence in part B we have to therefore explain why ABCD is a rhombus. Now one of the tests for a rhombus is that a rhombus is a parallelogram which has one pair of adjacent sides equal. Now we're told that ABCD is a parallelogram, and we've just proven that AB equals AD. Therefore, we can now explain why ABCD is a is a rhombus. And the reason is that ABCD is a rhombus because it is a parallelogram with one pair of adjacent sides equal. And that's the end of the proof.